Hello everyone, welcome back to this channel. Today we are going to learn about descriptive statistics. This simply means that you are interpreting the data without making any assumptions. How? Let me give you a simple example. Let's say in your class there are total 150 students and your teacher wants to know the average height of the class. So he can do this in two ways. First, he can measure their height and make an average. Second, he can simply select some students measure their height and make an assumptions about the average height of the class. Okay. So in first scenario, he is considering every student, he is measuring everyone, total 150 students. That means he is considering the complete population. So these techniques, these measurements comes under descriptive statistics. But in second scenario, he is considering some students, he is not considering everyone. So he is taking a sample from the population. So here the techniques comes under inferential statistics. Okay. So statistics can be divided in two types. Descriptive, where you are considering the complete population, total 150 students. And next one is inferential statistics, where you are considering some students, 10, 15, 20, any numbers, not everyone, the sample. Then it comes under inferential statistics. Okay, so today we are going to learn about descriptive statistics. Okay, see here total six types of measurements that comes under descriptive statistics. First one is measures of central tendency, measures of dispersion, measures of shape, frequency distribution, percentile and quartile. Next one is summary tables. Okay. Now first, how can we calculate the central tendency? By mean value, median value, mode value. Let's understand all these things in details. Okay. Now measures of central tendency means you are trying to identify where the most values in a distribution fall. Okay. So identifying the central point within a data set. Okay, so we have to calculate mean value. Mean is nothing but the average sum of all numbers divided by the number of values. Here I have taken a data set. Here you can see this is a list 85, 90, 88, 92, 87. So if I want to calculate the mean value or we can say the average value of the data set, I just simply can add 85 plus 90 plus 88 plus 92 plus 87 divided by the number of values, that is 5. So I can get the mean value. Okay. So here I can understand that the maximum values or we can say the most values in the distribution in this data set lies near 88.4. Okay. So if you have a big data set, you can simply identify the central point. You can understand where the most values lies in the distribution. Okay. Now there are other types of means also. One is weighted mean. Number two is trimmed mean. Weighted mean is used when you consider its corresponding weight. Suppose some values contribute more to the overall average than others. Like here, there is a data set 2, 3, 4, 5. But every data has different types of weights. So here if I want to calculate the weighted mean, I have to multiply each data point by its corresponding weight. Then summing all the products and then dividing by the sum of the weights. Okay. This is mainly used when every data set has different weights in the data set. Okay. So here I have just simply written a code like for x comma w in g data comma weights. G function will consider first value of data, first value of weight. So x will be 2, w will be 0.1. After it is assigned, they will be multiplied x into w. Then it will sum all the products and divide it by the sum of the weights. Okay, so simply this way you can calculate the weighted mean, but you don't have to do these things because numpy function has already provided np.average values, comma, that means data here, comma, weights equal to weights. So these two parameters will simply calculate the weighted mean from the data set. Okay, you don't need to write the coding because NumPy has some ready-made array. We have already studied these things in NumPy classes. np.mean, same way you can calculate np.weighted mean also. For that, you have to call the average function and pass the values. Fine. Next, understand trimmed mean. Trimmed mean simply means that removing certain percentages of smallest and largest values in the data set and then calculating the mean of the remaining value. Okay. So here in this array, you have to remove some smallest values, some largest value, depending on your wish. Like here, 10 percentage from both ends have been deleted, or we can say trim. Then you calculate the mean value from the remaining data set. That is what is trimmed mean. Okay, for that you have to call the trim mean function and you have to pass these parameters. Simple. So we have completed measures of central tendency mean value. Next one is median. Median means the middle value of the data set. First, you have to sort this. You have to make it ordered. Then you have to find the middle value, that is known as median. So it separates the higher half from the lower half. So you can understand the central point of the data set. Okay, for that you have to use median function in NumPy array. np.median x, it will provide you the median value. Fine. Now mode means that value which occurs most frequently in the data set. Here see 85 occurs once, 78 occurs twice, 92 once, 87 once. So what is the mode value here? 78. What is the count? Count equal to 2. So you can understand that what are those data which occurs most frequently in the data set. Okay. So we have completed the measures of central tendency. Mean value, trimmed mean, weighted mean, median value, mode value. Okay. Next, understand measures of dispersion. This is exactly opposite. Central tendency means you want to know the central point. Dispersion means how much the data is spread. What is the variability in the data set? Okay. So we can say how much the data values in a data set differ from each other, or we can say differ from central tendency. Fine. So how can we calculate this? First one is range. Range gives you the maximum values. The minimum values finds the difference between maximum value and minimum values in a data set. Here see, you can see there is a data set. So first you have to find the maximum value, the minimum value, then difference. That is what is known as range. So you can understand how much the data set is spread. Fine. Next one is variance. Variance simply means to find how much each number in a data set differs from the mean of the data set. Okay, suppose see here. First, I have to calculate the mean of this total array. So I can simply write np.mean, mean function in numpy array. It will calculate the mean value 2 plus 4 plus 4 plus 4 plus 5 plus 5 plus 7 plus 9 divided by total number of numbers. Okay, now when I have got the mean value, here the mean value is 2, 6, 10, 14, 19, 24, 31, 40 divided by 1, 2, 3, 4, 5, 6, 7, 8. That means 5. So here the mean value is 5. Now I want to know that each number in the data set 2, 4, 7, 5, 9 is how much different or how much differs from the mean of the data set. Okay. So 2 minus mean value is 5 minus 5, 2 minus 5, 3, square of 3 that is 9, 4 minus 5 that is minus 1, square of 1 minus 1 that is 1. Okay, same 1. Next, 0, 0, 7 minus 5, 2, 9 minus 5, 4. So 2 square plus 4 square. Now if I add all these squares and divide them by the length of the numbers, that is 8, then we can get the variance. So we can understand that every data set, every number in the data set is how much different from the mean of the data set. Okay, so how much the data set is spread. We can find the measures of dispersion. Now a simple question I can ask you that we can simply subtract this. But why we are making a square? We want to know how much it differs. So we can simply subtract. But why square? Because see, first it is giving us a negative number. 2 minus 5 minus 3. 4 minus 5 minus 1. Minus 1 minus 1. 0 0 2 4. Here it is giving positive numbers. So if I simply add negative numbers with positive numbers, then we will not get the desired result. That's why we are making a square so that the negative numbers also turns into a positive number and we can get what we actually want to get. Now spread out a set of values in the data set. Okay, that is what is known as variance. How much it differs from the mean value. Now next one is standard deviation. Okay, before that let me tell you one thing, that we don't need to calculate this much of coding. We just can simply use VAR function that is already in NumPy library. All you have to do, import NumPy library and apply the var function on this dataset. Then you can get the variance. Okay. So all this coding simply can be done in a single line. Fine. Next one is standard deviation. Standard deviation means the square root of a variance. Here we have made a square. So we just simply square root the result, the variance. So we will simply square root 4.0. So here 2 will be the standard deviation. See here. Okay. Here I have written a mistake. Here it will be standard deviation, not variance. Okay. So these are the simple things by which we can know how much the data is spread. Measures of dispersion. So as of now, we have completed measures of central tendency, that is finding the central point, finding the middle value. It can be done in three ways: mean, median, mode. Mean has other types of means also, like trimmed mean, where smallest values and largest values are simply removed and the mean is calculated on the remaining values. Second one is weighted mean. When every data set has different weights, we calculate weighted mean by multiplying each data points with its corresponding weights. Next, we studied about median. First, we have to order the data set. Then we have to find the middle value. So we can get the middle values of the data set. Next, we have studied mode. Mode means the value which is occurring most frequently in the data set. Okay. Next, we have completed measures of dispersion. There we have studied about range. Range, the difference between maximum number and the minimum number. Next, we have studied about variance. That means how much each values in the data set differs from the mean value. Next, as variance is calculated in square form, we are just making a root of variance and we find the standard deviation. So all these things, mean, median, mode, gives us the central point of the data, and all these things, range, variance and standard deviation, gives us the dispersion or spread of the data set, exactly opposite of each other. In our next class, we will study about all these things. Till then, bye. Happy learning.